This is Mr. Lee's physics class. I'm Mr. Lee. In this chapter, I'm going to talk about what temperature is and the different types of thermometers. As a common sense, temperature is a physical quantity that measures how hot or how cold an object is. There are different types of temperature scales. Three common ones are the so-called Celsius scale, the Fahrenheit scale, and the Kelvin scale. In HKDSE, you just have to know about the Celsius scale and the Kelvin scale. The Fahrenheit scale is just here for you to know. You don't have to really know the details of it. Let's start with the units. For Celsius scale, the unit is degrees Celsius. Please note that it is degree Celsius. Don't miss out the degree. The entire degree and C combined together is the unit itself. The Celsius scale is used worldwide except for several countries like the US, in which it used the Fahrenheit scales. If you are using the Celsius scale, then for example, if you measure the normal temperature of the human body, then it's about 37.0 degrees Celsius. Note that this is actually just an approximation because actually different people have a slightly different body temperature, and even for the same person, his or her body temperature can differ from time to time slightly. Next, the Fahrenheit scale bears the unit of degree Fahrenheit. Again, degree and Fahrenheit together forms the entire unit. Please do not miss out any part of it. The scale is used mainly in the US, and take an example, if we talk about the normal body temperature again, its value is about 98.6 degrees Fahrenheit. The last temperature scale to introduce is the so-called Kelvin scale. It is also sometimes called the absolute temperature scale, and it is used in mostly science. Actually, physical science is the most common one, and its unit is Kelvin. Well, notice that this Kelvin is just K. It doesn't have any degree before it. This is not just about writing. When we speak of it, we speak of Kelvin, not degree Kelvin. Take an example, if we talk about the normal body temperature again, is about 310 Kelvin, not 310 degree Kelvin. Up to here, we have talked about three different temperature scales, and actually you can think of it as just like measuring length in different units like cm and inch. So different temperature scales can be converted from this one to that one, very much like you can convert measurements of length from the units of inch to units of cm. This diagram shows you the approximate conversion between different temperature scales. For example, if you talk about 60 degrees Celsius, it corresponds to approximately 140 degrees Fahrenheit and about 330 something Kelvin. Of course, in physics, we prefer things done not just through a diagram but more mathematically through some calculation. And these two equations show you how to do it. For example, the first one shows you if you are given temperature in degrees Celsius, then you just multiply the degrees Celsius number by 9/5 plus 32. It will result in a temperature in Fahrenheit scale. The conversion from Celsius scale to Kelvin scale is even easier. All you have to do is just to add 273 to a temperature measured in degrees Celsius, then it results in a temperature measured in Kelvin. If this sounds all too abstract to you, let's work out one example, down here. The 2007 European heat wave is famous. It hits the southeastern Europe seriously, and Bulgaria even recorded a historically hottest year of a temperature of 113 degrees Fahrenheit. Now I want to convert this to a temperature measured in degrees Celsius, or the Celsius scale. To do this, we apply this conversion formula between the Fahrenheit and the Celsius scale. Then let's rearrange this equation such that Tc, the Celsius temperature, is the subject. This can be easily done by the following two steps. And finally, all we have to do is to just put the 113 into Tf, then the resulting value is 45 degrees Celsius. Now let's take a look at this picture. You can see that there actually can be a huge difference of temperature between hot and cold objects. For example, if we talk about the surface of the sun, its temperature can be more than 5,000 degrees Celsius, and for an atomic bomb explosion, it can be 10 to the power 7 degrees Celsius. That is literally 10 billion degrees Celsius. And indeed, there is actually no upper limit for high temperature. But on the other hand, there is a lowest possible temperature in this world, that is negative 273 degrees Celsius. Nothing can fall below this temperature. And so we also call this negative 273 degrees Celsius absolute zero, meaning that it is absolute. Nothing can be lower than that. You may wonder, why is there a lowest possible temperature in this world, but there is no upper limit for high temperature? This actually can be explained in terms of the particle theory of matter, and we'll discuss this soon.